Welcome everyone to today's webinar, Mechatronics, What You Need to Know and Do. I'm particularly excited today because we have on this webinar registrants from 24 states and 4 countries, including the United States. Pretty exciting to have this large level of interest. Now among those states, I did some counting here. Florida is the winner with 13 registrants, followed by California and New York with 10 each. That's pretty good. Michigan has 9, Arizona and Wisconsin at 6 each, and our friends up north in Canada, 7 registrants from Canada. From our countries outside of the U.S., we have people from Peru, Spain, and India in addition to Canada. So welcome everyone to this webinar. We, as all of you, are fascinated by this topic of mechatronics. So our title today is What You Need to Know and Do, and hopefully we're going to achieve that. Look at our presenters today, a very interesting mix. Let's start with Julian Serta. He's the Senior Technical Training Specialist at GlobalFoundries. They're headquartered in Malta, New York. Julian, how long have you been working at GlobalFoundries?
Hi everyone, it's Julian. Yes, I've been here 3.5 years.
Were you in Austin before then? Did you come directly from Austin?
Yes, I did. I lived in Austin for 18 years, and I had opportunities to work with MATEC, AMD, and then later on with Spansion, all semiconductor related companies.
Exciting. Thanks for joining us today, Julian. And Don,
glad to be here.
Don Garrison, also at GlobalFoundries. Don, say hello to us, and I think your path to GlobalFoundries managed somewhat to go through Arizona, didn't it?
Yes, it is. Welcome everybody. So my name is Don Garrison. I actually was born and raised in Arizona. Started my career at Intel about 19 years ago, and then had the opportunity to work for Intel for several years, and then came on to North America and then GlobalFoundries now.
Cool. Don, let me ask you a question. I'm not sure everybody online knows what GlobalFoundries is and exactly what they do. Will you give us a 25-word description of GlobalFoundries?
Yes, I can do that. So GlobalFoundries is a foundry where we produce semiconductor chips. Basically, it's a wafer fab manufacturing facility where we produce material for other companies that need additional capacity. So we don't produce our own devices, but rather produce devices for other companies.
GlobalFoundries is I think one of the most high-tech manufacturing areas I've ever seen. And what's the price tag for your installation there in rough terms up in Malta?
In rough terms, upwards of $6 billion plus. By the time you figure in the building and equipment, and that price is continuing to grow as we bring in more tools and more manufacturing facilities here. So we're expecting it, when it's all said and done, to be about a $20 billion site. Last I heard.
That's stunning technology investment. Well, again, thank you, Don and Julian, for joining us from the industry side. Now, from the academic side, we have Gary Morgan. As you see, he's Dean Emeritus at the College of Lake County. What are you doing now that you're emeritus? Gary, what are you doing now?
Yes, Mike, and welcome everyone. I'm serving as the team lead for the development of a Mechatronics Certificate through a TAC grant that was funded to Anne Arundel Community College in Baltimore.
One of those Department of Labor TAC grants. I heard they're a pain to manage, but they're exciting because of all the support they bring to the community colleges.
Absolutely, and particularly now, Mike, because we're in the implementation phase, so a lot of the heavy lifting has already been done.
Excellent. Thanks for joining us. And also with us on the line is Marilyn Barger. She's the Executive Director of the Florida Advanced Technological Education Center. Maybe that's why there's so many people on the line from Florida. Welcome, Marilyn. What do you actually do at FLATE?
What do I do at FLATE? Well, I run our center. Good morning, everyone, or afternoon, I guess, for most of us.
Yes.
As Executive Director, I run the activities that we carry out throughout the state, and our mission is to work with the technical programs that support manufacturing in the state of Florida and the 2-year colleges. So I work with large number of colleges in the state of Florida and their programs and some of their feeder high schools to get the best technicians out to our manufacturers in Florida.
That's perfect, and thank you for joining us. Let's go forward, folks. Today, here's our objectives. Number one, we want to discover why. That is, why industry values mechatronics, skills, knowledge, and abilities. Julian's going to address that. We also want to describe what a mechatronics technician does in the workplace. And substituting for Clay in this position will be Don today. Excuse me for not making that change. Number three, we want to present educational approaches to developing mechatronics programs. We'll hear from Gary about that. Marilyn is going to take a look at some best practices and fire a bunch of questions at our industry and academic presenters today to engage them in a discussion about mechatronics. And then finally, on number 5, we're going to turn back to Don and have him sort of see where industry sees the value, what they're looking for and the value they get from mechatronics technicians. So interesting today, strong voices from industry and academia both. Well, why don't we start with the definition. What is mechatronics? Well, there's a lot of definitions out there, but this is a pretty good one. So let's take a look at it. Mechatronics is the synergistic combination of precision mechanical and engineering and electronic control and systems thinking. So I like that, right? Mechanical, electronic control, and systems thinking in the design of products and manufacturing processes. I think many people from industry value that word, manufacturing processes, not only the design of products, but the use in processes as well. Now the second sentence says, it relates to the design of systems, devices, and products aimed at achieving an optimal balance between basic mechanical structure and its overall control. So it's pretty cool, and you can see the reference to that definition there. I imagine there's many out there that you can reference as well. Let's go ahead and get started today by me asking you a question. Does your institution have a mechatronics type of program, a mechatronics type of program? So will you please use the polling box. Go into the upper part of the screen. I can see many of you are clicking on it right now. I mean, you probably know the answer. It's either yes or no. You have a mechatronics type of thing. Look for those 4 horizontal icons above everybody's name, and just go ahead and click on it. By the way, if you've got one, why don't you put it in the chat window, what it's called. We'd be very interested to see in the chat window what your programs might be called. Well, you can see a number of people that called them mechatronics. I guess that's not too surprising, is it? So everyone, thank you for that input. I'm not going to give you much more time to answer the poll, folks, because you know the answer. It's either yes or no. So let's see, where's my polling button? All right, here's the countdown for the poll. 5, 4, 3, 2, 1. Let's take a look at the responses. Very interesting. Gary, Don, Julian, we have a slight favoring for those that do have programs online. About, I don't know, a little more than half of the respondents who are responding here have programs and the others don't. So a very interesting mix. As I look in the chat window, you'll see an interesting program that's called Applied Integrated Technology. Others that's simply called Mechatronics. Some have more than one. In New York State, there's the Mechatronics Certificate and Associate programs. Engineering Technology is another one. In Florida, it's the Mechatronics Certificate. And there are several proposed ones. One is in Mechatronics Design. Another is Electrical and Mechatronics Engineering. And I think, presenters, what this means is what we already know. There's many ways of looking at this equation of what mechatronics is and how it's implemented. So let's go forward today. I'm now going to turn the floor to Julian. Julian, I'm looking at the slide that says why mechatronics. Your picture is in the upper right corner. That's how the audience knows that you're talking to us. So why don't you just go ahead, Julian.
Okay, thank you, Mike. And once again, good afternoon, everyone. before I move on to the next few slides, I want to give you a little background about my experience. I have worked in both the public sector and in industry for about 40 years in developing and designing and delivering training and educational programs, mostly for developing technician skills. And everywhere where I've worked, I have always worked very closely with community colleges and assisting them in their curriculum advisory committees to help them develop the training programs to prepare entry-level technicians for the semiconductor industry. And since my arrival here in New York, in Malta, New York, I've been doing the same thing with many local initiatives in this area. So why mechatronics now, and how did I arrive at the conclusion that this type of program could help prepare entry-level technicians to work as equipment technicians for global foundries? So we can flip to the next slide, Mike. And some of you may know that SMT programs got started and evolved in community colleges in the early 1990s. As the co-chair of the MATEC Technician Training Council between 1993 and 2005, I saw the number of SMT programs grow from colleges ranging from Oregon, Arizona, California, all the way to Texas, New Mexico, and Massachusetts. So these SMT programs are growing all over the country. Heavy investments were made in the building of simulated clean rooms and basic process equipment that were used in the community colleges. However, the demand for semiconductors gradually started to drop, and by the middle of the first decade in this new century, the industry started to experience ongoing layoffs and closures of some wafer fab facilities. And so as a result, the enrollment in community colleges for SMT programs started to drop as well. And as a result, many colleges, and we'll flip to the next slide, workforce demand changed. So community colleges that had developed these SMT programs then started realizing that they needed to diversify and not focus on any one particular industry like they did with SMT. And so then they started curriculum advisory committees suggested that they maybe focus on developing skills that could be used by graduate technicians in a variety of industries. And so some programs, some colleges developed electromechanical programs, advanced manufacturing, industrial technology, and mechatronics. So we can flip to the next slide. So, moving forward in 2010, when I arrived here in Global Foundries in Malta and met with many of the Malta managers, I pretty much decided that what I needed to do was to do a skills assessment to find out what kind of skills would be needed of equipment maintenance technicians here in Malta, New York. And I knew that MATEC had developed a equipment technician skills standard assessment back in 2000. And so I contacted Mike immediately and asked him for a copy of that assessment in a Excel spreadsheet. And this particular skills standards assessment was developed in cooperation with a number of semiconductor companies, and I believe there were like 47 technicians that were interviewed to be able to get the types of competencies that are used by equipment technicians in a 300 millimeter wafer fab. So we can skip to the next slide, Mike. So this slide shows the 47 subject matter experts from Arizona, New Mexico, Texas, and Vermont, and you can probably guess which companies were located in Arizona and New Mexico. That was probably Intel, and Texas Instruments, and possibly Motorola. And in Vermont, I would imagine it was IBM. So these technicians were interviewed, and they identified 22 skill categories, and within those 22 skill categories, there were 247 competencies that were reviewed, and these technicians were interviewed to find out which of those skills do they use on a day-to-day basis, and how important are they, how critical are they to the job, and how difficult are they. And so having this information really helped, because then I took this information and presented it to the managers in Fab 8 and Global Foundries, and I asked them to assess their what they felt were important skills and which ones were not. And so I'm going to go ahead and flip over to the next slide. And so what you see here in this first slide is the first 11 categories of these skills. And the numbers on the right indicate the value or importance that the managers placed on these particular skill categories. Okay, 3 being the highest and 0 being the lowest, and I don't see any zeros here, but the ones indicate that these are nice to have, but not extremely important as far as Global Foundries is concerned. And what the managers are indicating here is that these are the skills that they feel are really absolutely important, that entry-level technicians have when they come in the door and they come in to start as entry-level technicians. They should have these skills with them. Now, the skill category number 3 and 4, you see, it would be nice for technicians to come already with operating equipment skills and processing wafers, but the thing is, there's no way that schools or colleges are going to be able to duplicate the kind of equipment we use in our wafer fab. They're not going to be able to process 300 millimeter wafers. So our manager said, that's not important. What we think are important are these other things, like, for example, troubleshooting equipment of a variety of types, like electrical, pneumatic, hydraulic, electromechanical, and vacuum systems. Those are highly important. Okay, so you get an idea of which kinds of skills are preferred by Global Foundries in Fab 8. Okay, so let's turn to the next slide with categories 12 through 22 and get an idea which categories are considered highly important. Most of the 22 categories are extremely important. So then I sent the same assessment tool to 6 or 7 community colleges in our region here, and I asked the department managers of the different programs in the community colleges to do a self-assessment to find out how they rated themselves or their programs against these competencies. And so they all sent me back their self-assessments, and then I lumped them all together and averaged them out, and I came up with these numbers on the right. So on the right you see community college statistics, and you see the numbers. Well,
Julian, how many colleges was that you did these self-assessments?
I don't recall exactly how many there were, but between 6 and 7.
Yeah, I thought you were telling me 7. Yeah, that seems about right. Okay, go ahead.
Yeah.
Good. We're on the right side. Yeah.
Okay. So the items that you see that are in a rectangle, a red rectangle, these we indicated as being skill gaps. We rated these particular skills very high, but the community colleges here indicated that they didn't feel they had a strong enough program, or maybe they didn't have a program available yet to cover these particular areas. So this is what I refer to as skill gaps. These are things that we need but are not available. So it indicated that something needed to be developed, either through the colleges or within Global Foundries. So I'm moving on to the next slide, Mike. And so we continue here with the skill categories 13, 14, 16, and 17, and you see those are skill gaps for us. We say these are the most important skills that entry-level technicians need, but the community colleges don't yet have the programs available to help us out. Okay, so I'm going to skip to the next slide. What's the impact of these gaps? Well, to us, it's going to mean that if entry-level technicians don't come equipped with the skills that we need, this is going to increase the learning curve for entry-level technicians. That means that our senior technicians are going to be spending a lot of time training these entry-level technicians on skills that they should already have. As a result, the mentor's time and the trainee's time means it's going to cost us dollars, and then there's greater impact. So next slide, more impact. So if we have unskilled, not yet certified technicians, these uncertified technicians cannot perform tasks and jobs that are required, where the certifications required. This increases the workload for certified technicians, and that, as a result, some work will be delayed because we're having to take time to train technicians that are not quite ready for being able to do work independently. All right, so next slide, strategy for closing the skill gaps. So out of all of the skill gaps, we decided that the most important ones that we felt needed to be addressed by GlobalFoundries and our community college partners here. And don't get me wrong, our community college partners here are working very closely with us to develop some of these courses. Most of the work we're doing with are with Fulton-Montgomery Community College, Hudson Valley Community College, Mohawk Valley Community College, and SUNY County Community College. And these are the ones that we're currently working very closely with to help us develop some of these courses. So you see the ones that we considered to be at the top of the list include pneumatics, hydraulics, electromechanical, vacuum, RF power, and automation. And then, by the way, the basic safety, although it's not included in this list, all the colleges understand basic safety should be included in each one of these courses that are covered, so that at any time when they're developing courses, they also include the basic concepts of safety, including lockout, tagout of equipment. So I did some, while I was in Texas and before I came to work here, I had had an opportunity to visit the Texas State Technical College campus in Harlingen, Texas, and I got a tour of the Mechatronics program there, and I was really impressed with what I saw. And this is the logo from that college, and you see, Mechatronics seems to be a kind of a program that provides the skills and knowledge for students to be able to work in a variety of different fields like aerospace, medical, defense, manufacturing, automotive. So moving to the next slide, I had an opportunity last summer to attend the MATEC conference in Austin, Texas. And while there, I had an opportunity to sit in on a presentation that was delivered by Florida State College at Jacksonville. And I saw this curriculum, and I thought, wow, this course here has most of everything we need to fill those skill gaps that we have back at GlobalFoundries. It's got mechanical devices, hydraulics, pneumatics, robotics, mechatronics, motors, controls, manufacturing processes, and OSHA safety. And I said, well, I thought, and this was a one-year certificate in mechatronics, and it started to look very attractive to me. And so as a result of this, of course, we contacted Maryland in Florida State College, and we are now working here in this area with SUNY County Community College, Fulton-Montgomery Community College, and Hudson Valley Community College. We're working together to try to institute this kind of one-year certificate in mechatronics as well. I'm going to skip to the next slide now. Fulton-Montgomery Community College Mechatronics Training System.
Okay,
this is
we're
the
right
training
there.
system. Okay, this is the training system that's used by Fulton-Montgomery as part of their mechatronics training. It's manufactured by Amatrol, and it's kind of like a manufacturing system and it's got different methods for conveying materials from one place to another. Each one of the stations, I think this one has about 7 stations. Each station is controlled by a PLC, and so students learn how to program PLCs, and they also learn how to be able to control, to program the system so that it's able to transfer material from one location to another. So it uses electronics, pneumatics, electromechanical, motors, sensors, actuators, robotics, and there's so much that they can learn from this. And we feel that having this kind of training, and if we could get all the technicians that come to apply for jobs at Global Foundries, it would provide for us a fantastic baseline of entry-level skills that would really help get technicians up to speed much faster. So in the long run, it would save us money and time if technicians had this kind of training coming into work for Global Foundries. Yeah, so going to the next slide. This slide shows you the curriculum that's being proposed for with the TAC grant that has been provided to the State University of New York, and is working with community colleges in this area. So you see this program is very similar to the Florida State College Mechatronics program as well. This is also a 1-year Mechatronics Certificate program. It's pretty much a copy of what they've done in Florida. Okay, so that pretty much covers it for me. Now I'm going to turn it over to Don, and Don will introduce you to a day in the life of a mechatronics technician.
Okay, well, good afternoon, everybody. Like Julian, I'll just go ahead and give you a little bit of background into my experience. I started off, as I mentioned before, at Intel about 19 years ago. I started as an equipment technician at Fab 6, and a few years later I accepted a position in the equipment engineering, basically mechanical engineering group, where I was a tool owner, and a few years after that I decided to jump into the management role, and I've been in the management role for about the past 11 years, managing mainly equipment technicians and equipment engineers, up until recently, the last 6 months, taking on the technical training initiative for all of the Malta site. The reason I took on the technical training initiative here for Malta is I do have a passion for the technicians, role in the engineers, and supporting them and getting the tools they need to be successful. And I identified some gaps that I was seeing as a manager, as a section manager within the engineering ranks. And I basically want to bring my observations to this team to support and come up with creative solutions on how to close some of those gaps. So the surveys that Julian is referring to, they're all parts of feedback that myself and the other managers gave. Obviously, he did that before I came on board, but they kind of mirrored the concerns that I have. So the day in the life of a mechatronics technician. Technicians in a high volume, I'm on this slide that says technicians in a high volume manufacturing environment. They need this following skills, right? They have to have both hands-on technical and soft skills. One of the biggest skills that our technicians must have is effective communication. And what I mean by that is we're going to talk about a lot of the mechanical aptitude and electronics skills they need, but if they can't effectively communicate what they've done or what needs to be done, it really sets them up for failure in the work environment. They also work with hazardous materials and equipment. So we have very strict safety requirements, not just OSHA, but we also have additional safety requirements because we have a zero tolerance for that. So they must have understanding of how to deal with those different types of materials and equipment. They also work on high dollar complex systems. Now, what I like to attribute this to is as people ask me, what are the skills of a technician? It's basically like working on a $140 million Ferrari. So some of the pieces of equipment we have just for one single piece of equipment is $140 million. On the low end, we have pieces of equipment that are only $3 or $4 million. But basically, within the next year, we're going to have over 1,000 pieces of equipment in the factory. So 1,000 pieces of equipment ranging from anywhere from $2 million, $5 million, up to $140 million. So that's what I mean by the high dollar complex system. They must have mechanical aptitude, as I said, similar to an automotive mechanic, but also the attention to detail and the discipline of the aircraft technicians, right? Following procedures and making sure that every I is dotted and T is crossed. And the technicians are more than just, excuse me, I went to the next slide. They're also more than just electronics focused, right? We have a lot of technicians that come in here with a strong electronics background. They'll go out and get an electronics degree because those degrees are readily available. But that's a very small portion of what they do in their day-to-day jobs. They work with automation, they work with pneumatics, vacuum, RF, and depending on what role they're in the factory, countless other different skills are needed besides just the electronics. One of the biggest things that they need to have, along with communication, is they need to understand troubleshooting methodology. They have to understand problem solving. They have to understand critical thinking. These are individuals that are working on these complex systems, and they have to be able to kind of think outside of the box, be on the best and most quality way of bringing the tool back up to production, because every hour that the piece of equipment is down costs the company a substantial amount of money. And so, we really rely on them having those skills as well. And also the technicians, they're not like the technicians of 50 years ago where they kind of just sit on the assembly line and do their job. They have to interact with manufacturing operations, process engineering, equipment engineering, the facilities, the equipment customer services engineers, managers, and so on and so forth. A daily part of their job, which ties back to the communication, is being able to work well with these other individuals in a teamwork environment, communicating effectively, and being able to not only for themselves be successful, but the success of the team as well. And so that's basically the day in the life of the technician. Mike, we'll go ahead and turn it back over to you.
Well, thanks very much, Don. There's a series of questions here. Let me take advantage of both you and Julian. You were just talking about the need for hands-on skills, and you can see some back and forth in the chat window talking about that Fulton-Montgomery system from Amatrol and how much it costs and what it can achieve. But is there an intimidation factor? Here's a question for you, right? You've got a student who's been through our programs, comes into a place like this where there's, I've been inside these fabs, and they can be intimidating at the complexity level. How do you deal with that, or can you deal with that?
Absolutely. So there is certainly an intimidation factor. So we have what we call the shock and awe factor. When technicians come out of a lot of the programs, especially when it's just an electronics-based program, when they walk into the factory the first time and they see a 500,000 square foot clean room or 375,000 square foot, the next one will be 500. When they walk in that the fab and they see all these complex pieces of machinery all lined up in a row, it becomes very intimidating. And so when they look at those pieces of equipment that range anywhere in size from a Volkswagen bus to an 18-wheeler, they can get really intimidated as well because they see the whole tool. So what we hope for is, as we see individuals that have come out of similar programs to these, is they tend to look at the tool on the component level. So they're able to identify things like pneumatic valves, and they think, oh wait, I know what that is, or they'll see other robotics, automation, and they can kind of take it back and break the tool apart into pieces and realize that their education will actually enable them or give them the tools they need to do their job because they're not looking at the tool as a whole. So it does take off that intimidation, because right now when we get a technician that is intimidated coming into the factory, it's very challenging to get that person engaged because they're so afraid of making a mistake. They're so afraid of costing downtime, which costs revenue because everybody puts that dollar figure to everything. So by having that intimidation taken off, they're able to get engaged much faster. So not just with skills, but the intimidation. Does that answer your question?
Yes, it does. Are you able to bring in students on a internship sort of basis? I imagine that's another way of helping them adjust to the environment as well.
Right now, we do not have concessions for bringing students on in internships. We do have some students that are here from Abu Dhabi that are on an internship. This is the first time we've ever done this kind of a program. The reason being is because there is such a high dollar, cost associated with mistakes. And not to mention the safety implications, we really don't allow interns to come into the factory and work. It's mainly to protect the students as well as the process and everything else. It's not saying that we won't in the future, but as of right now, we're just not at that stage.
Sure, that's understandable. Ben, if you look, you can see some interesting conversations in the chat window have to do with essentially there's many ways of skinning this cat, so to speak. There's CAN training systems. You mentioned the Amatrol one. There's people that develop their own, whether you use CAN curricula or write your own. There's many different ways that colleges around the country approach this, but I think if they connect with their industry partners like you, they can really help them focus, help them get the right hands-on skills so that when they come to you, when they come into the work environment, they're ready to go. Their times of productivity is shortened by having that sort of experience with you. So,
absolutely. And Mike, if you don't mind, if I can make one more statement. One of the things that we do try to do with our college partners here is also working with them, and we'll actually give tours to some of our educators so where they can come in and kind of see what we're referring to. That way, part of their education process can be talking to the students about what they're going to see to help prepare them. So they kind of, we do things like, we get things like videos to them. We're working on getting like videos for them to show the students and things like that, so they can at least see what it's like and they can explain how to break the tool apart to the component level so they're not as intimidated. Even those conversations and that teaching helps, even if it's not an internship in the factory. Does that make sense?
Yes, it does, Don, and thank you. You know what, for the interest of time, or our timing is just perfect right now, so I think we're going to go ahead into our next session, and we'll have another opportunity for questions as we get a little bit further on in our presentation today. Let me turn over the floor now, if I could, to Gary. Gary, you go ahead, and you're in charge of the slides now yourself, and tell us about that Mechatronics Certificate program. Go ahead.
Okay. Welcome, everyone. As I said previously, I retired from the College of Lake County as a dean, and I'm currently teaching an electrical systems course in the certificate that we developed on an adjunct basis, as well as leading the faculty development team through this grant to develop the program. And just to give you just kind of a very brief background, the development team that I'm working with has faculty on it from Anne Arundel Community College in Baltimore, Cuyahoga Community College in Cleveland, Florida State College at Jacksonville, the college's program that Julian referenced earlier, Ivy Tech in Valparaiso and South Bend, and Roane State in Oak Ridge, Tennessee. Those are the 6 colleges that I have brought together to develop a 30 credit hour Mechatronics Certificate. And just a couple of comments about it. The 30 credit hour certificate has an 18 credit hours that makes up the core requirements. And then we have 12 credit hours that we call selectives. So depending upon the college's demographic and the industry that they're serving, pardon me, they can select from those selectives to meet the needs of their industries. So for example, the programs that Julian was referencing in the semiconductor industry would select a selective in RF power and vacuum systems. We have selected different selectives because we don't have a semiconductor industry, but amongst the 6 colleges it could range from a CNC course for selectives to welding, to industrial robotics, to advanced PLCs, to a industrial safety course. But the work that we did is around 18 required credits and then 12 selective courses. Just a little background, all 6 colleges have completed the implementation of the first cohort, and the second and third cohorts are underway. And we have served about 230 50 or so students. Moving on to the next slide, in terms of how our team defined mechatronics, we had to go back to see what our industry folks were asking for. And to make a fairly long story short, industry had a demand for multi-skilled technicians that could troubleshoot at a system level. So that, if you would, was our starting point after receiving the input from industry. And we use a similar logo that Julian referenced down in Texas. And we defined what our graduate will be able to function as. We say it would be an entry-level technician position who can work at the modular level within a mechatronic system, not at a component level, but at a modular level, and be able to analyze and troubleshoot at a system level. So those were really the biggest challenges for our development team, to focus at modular troubleshooting and system level troubleshooting. And again, you can see from the logo that it's a marriage of mechanical, electronics, and information technology. Now, even though our project was focused on developing a one-year certificate, we have had numerous conversations about linking it into an associate in applied science degree. We feel as though for a student to be more employable, we really need to have a degree, but we wanted to start with the certificate initially. Advancing on then, the curriculum work that we have done over the course of the past 2 years will be available under a Creative Commons license starting on September 30th of 2014. And it's going to be housed in a national depository at Carnegie Mellon, and there will be no cost to anyone that would want to adopt our work. And just, if I could, to give you a little summary of what will be in there, because our team has worked very hard. There will be course syllabus for all the required courses, a very detailed syllabus. There'll be weekly lesson plans. There'll be lab activities, and then what we call other instructional tools. Those are PowerPoints, exams, maybe lecture notes, or anything, if you would, that would be in the toolbox for a faculty member that was teaching the course. If we advance on and take a look at what the titles are of positions that are closely related to the target that we were shooting for those of you in the educational arena, you know that we look at things called SOC codes. And unfortunately, there's not a SOC code for a mechatronics technician because it's a relatively new term. But I listed some supporting SOC codes for those of you that may be looking to develop a needs analysis and begin looking at some state data. And those are some titles of occupations that are already recognized by the federal government. And I listed them there, and I think most of you that are in manufacturing programs have seen those things before. Advancing on to the actual certificate offerings. Now, these are the offerings at the College of Lake County. As I said earlier, some colleges, depending upon where they're located, may choose to have other selectives. Like, for example, our colleagues in Cleveland at Cuyahoga use a welding course as a selective. But these simply are the courses that we're using at the College of Lake County. And our primary large employers in this area is in the pharmaceutical area. We have Abbott Labs here, and we also have Baxter. So as far as the certificate offerings, these are all 3 credit hour courses. We're offering one on autonomous robots, mechanical systems, electrical systems. We've got an introduction to PLCs. We have what we call a fundamentals of high-tech manufacturing course, and pneumatics and hydraulics. Those are the core courses that we have adopted here at the College of Lake County. And I would like to say just a couple of words about these courses. When we developed them, keeping in mind we developed them around the idea of graduates being able to think at a modular level and to be able to system level troubleshoot. And I think that was our biggest challenge in developing the curriculum. As most of you are familiar with manufacturing, these courses are, they've been around for some time in some capacity. But really our challenge was the pedagogy on how we teach that in order to think at a systems level and not get all caught up at the component level, but think more at I kind of hate this term, but black box type approach or modular level. The courses that you're looking at for the certificate, all the curriculum has been developed in 20 credit hour modules. So for those of you looking for curriculum, the curriculum is written to be flexible, where you could, if you wanted to offer it on an accelerated format, or you wanted to offer it on an open entry or open exit format, it's structured so that it can be flexible. Advancing on, you can see the remaining courses in our certificate. We have an advanced PLC course, we have an engineering CAD and drafting course, and then we have our capstone systems level course. Now here at the College of Lake County, we use the Amatrol system that Fulton-Montgomery has. It has worked very well for us at the systems level. But certainly it is not an end-all for the equipment that would be required for the other courses, but it worked very well at the capstone level. One of our other partner colleges, Anne Arundel, is using a system from Festo, which reports are that it's working well. We're not using anything from LabVolt or other vendors at this time. The two that we seem to have settled in on after a number of webinars was either the Amatrol system or the Festo system. The curriculum that will be available will also have 3 modules. Each of these are 1 credit that we call STEM Readiness. And the first module really is a module on contextualized math for mechatronics, because many of our students come in lacking the math skills that they need. So we wanted to try something that might help us improve retention and bring them into the program and then teach them the math that they are missing within that STEM Readiness course. The other 2 readiness courses, STEM Readiness 2 is on critical thinking and problem solving, and then STEM Readiness 3 addresses the topic of what I would call soft skills, and those are all of the other skills that Don was referencing in his presentation and the importance of those. So as I speak, that's what we're offering at CLC. The 6 common core courses that I referenced are being taught at all 6 states, and then the selectives will vary depending upon the demographic that you're at. I've referenced a little earlier about the challenges, advancing to the next slide, the challenges that we had with the team on how we address system level teaching. Sometimes that's easier said than done. Some of the inadequacies that we saw in the traditional method of teaching was that it lacked any subsystem interrelationships. So how do the electrical systems tie in with the hydraulic and pneumatic systems? We definitely saw a lack, at least amongst our 6 states, that there was no system integration. They were learning a great deal in each area, but there was never really an opportunity to bring it all together and teach those skills that are needed at that level. The same thing with a comprehensive plan for systems analysis and system troubleshooting. So those were really the heavy lifting points for us and for the faculty on the team to figure out how we build those kinds of activities into the curriculum so that students have those important skills that they need. And I feel pretty confident now after 2 years of implementing the or 2 years of development. We're in the implementation phase, and now we're kind of in the rewrite phase where we've taught them now and we go back and say, okay, what needs to be changed? Are there things we missed? And so forth and so on. So from that standpoint, that's kind of where we are with that development at this point. Advancing on, if you have some time, there's a YouTube link there of a video that the 6 colleges put together on our program. And it's about a 4-minute video, and it's various shots from each of the different colleges. And it really is just a tool to help communicate and market what a mechatronics technician is and the kinds of skills that are important within those programs. So if you get a chance, or if you're looking to develop something similar, by all means, you're welcome to use anything that we have here. Advancing on to industry recognized certifications, we as a development team felt that we wanted a third-party evaluator to take a look at the outcomes of our students. And after a fair amount of research on certifications that are available, we selected as a team the Siemens certification. The Siemens certification has 3 different levels, and our certificate prepares them for what I call about a level 1.5, but there's only a 1 and a 2, so they set for the level 1 certification. The Siemens certification does not require that everything be taught on Siemens. We do teach Allen Bradley in our PLC courses, but on our capstone trainer, the one that's at Fulton-Montgomery that you saw, we have Siemens PLCs on that capstone so that it gives students an experience on another PLC, and it also prepares them for that certification. But that's really the only requirement for Siemens as far as getting approval to offer their certification. Now there's other approvals that they require, but from a curriculum standpoint, as long as they have some exposure to Siemens PLCs, they should do well. The other cert, if you recall, I referenced a course called Introduction to High-Tech Manufacturing. That's a course that we developed that prepares students for the CPT MSSC exam. And that course is the only course within the certificate that is taught online. And we have taught that a number of times at a number of different locations. There's also a SolidWorks certification if you were to select the engineering CAD and drafting course as a selective. If we continue on, there's a contact information slide there. That's myself. Please feel free to contact me if there's anything that I can be of help with you on, although the curriculum won't be available nationally until the fall of this year. I do have the curriculum, and certainly it's something I can share with a little caveat that there will be some modifications to it as we have taught the the courses and revised them and then gone back and made some changes. And I would, if I could at this time, just like to take a minute or two in reading some of the chat questions dealing with equipment. At the College of Lake County, we had a fairly well-equipped PLC lab with trainers that we made with in-house. And we had a decent pneumatics lab. But we did have to purchase equipment for the electrical systems course that includes motor control, and the mechanical systems course, and of course the capstone course. And we chose to go with a third-party provider for those because of their curriculum, because we plan to move our program to a multiple entry point program where students can enter in at least twice during each semester. We felt we needed curriculum and labs that could adapt to that particular delivery format we were using. But as far as the College of Lake County, we invested a little over $400,000 to get the program up to speed. That does not, again, take into account equipment that we had that we used out of an EET program or an MET program that fit in. But for us, it was around the $400,000 mark. Again, I'm very happy to share anything that I can with you. I certainly don't have all the answers, but if I don't have an answer, I can direct it to one of our other team members within the consortium. And I think that's it.
Good, thank you, Gary. Very fascinating, especially for the level of resources that you have now, or certainly in the fall, available. That's really important to us. We enjoyed your comments as well on the equipment. One quick question, and we're going to move forward for the purposes of time. You mentioned that STEM readiness course. In the process, the three of them, in the process, did you develop a set of STEM competencies for those courses that drove that development? People are interested in that.
Yes, that was the first step. We developed competencies, and we had an industry advisory panel that worked with us. And then from there, these STEM readiness courses are all delivered online. Now, we also have an instructor in the classroom to help facilitate it and coach it, but they've all been it's all been set up to be delivered online.
Cool. I bet you're going to get a couple of emails about that, Gary, at your gmorgan@clcillinois.edu address. So thank you again. Let's move forward, folks. Let's invite Marilyn Barger from FLAE to come on the line. There you are, Marilyn. There's your picture on the upper right there. Go ahead.
There I am. Okay. Wow, that was some great information from the folks at Global Foundry and also Gary Morgan. I'm going to give you a little background on my involvement in mechatronics before we go forward. And Gary, don't go far. I have some questions for you, and same for Julian and Don.
Okay.
Okay, so I got involved a little bit with the program that Gary has just elaborated on quite nicely at the very beginning. Because Florida State College at Jacksonville is one of our partners in the FLAE Center. And the folks there came to me and said, we're going to put this mechatronics place in, help us fit it into our existing degree program. And for us in Florida, that means we have to go to the Department of Education and submit a bunch of paperwork and the skills and competencies, justification, and that kind of thing. So I was involved with the program development and Gary's team at the very beginning for several months. So I worked with Jacksonville particularly to get the program ready for Florida. And during that time, realized there was just a whole lot of buzz about mechatronics everywhere, something I hadn't been focused on before. And so started paying a little bit more attention to decide if it was something we really needed to implement in more places in our state and some of our other college partners. So one question that I have for Gary right away is, what's you had a mechanical program and an electronics program, I believe, technology program. It always seems like these are kind of close to a mechatronics program, and so what's the drive to make move to mechatronics? And did it come from industry? Or was it you and your industry partners together trying to figure out which of these two programs was a good fit, realizing it wasn't neither one were the right program or something like that?
Well, Marilyn, the initial drive came from our industry requesting multi-skilled technicians. And when we looked within our programs, we have an MET program and an EET program, but they weren't meeting the needs of the multi-skilled tech. So being that we were developing at a certificate level, we initially have tied our certificate into an MET degree. So it's kind of a subset of MET. We wanted to have a parent program for it, and that seemed the best connection for us. Our next step here is the associate degree for mechatronics. So our MET program, may go away, or it may change depending upon how the mechatronics associate degree develops. But we do see the importance of having a degree. From an employer standpoint, I think our employers are looking for a minimum of an associate degree, and quite honestly, our students want that as well. They want more than just a certificate. So to answer your question, our connection was an MET program. That answer your question? Hello?
Sorry, Gary.
Marilyn, don't
yes,
forget these are talking. Yeah.
I think it's always a struggle for our academic colleagues to get out from underneath existing programs, because they know they have a lot of the courses. It just now happens they're in different locations, and trying to find a way to re-engineer those programs to better meet the current industry's needs is always a struggle for us. We just from our own backgrounds and where we came. So I think your experience in just going through that is probably valuable to a lot of folks who are struggling with that right now, or might be in the future. So thanks for those comments. I think it's important for us to learn about that as well. So I want to chime in a little bit on the certifications, and then ask Don and Julian a couple of questions. I think the certifications are great tools for us when we're building programs and courses. They really give us a nice, quote, voice from industry, using some of the language that we often need in academia when we're developing curriculum. The very well-defined skills and competencies, and you saw some of those in Julian's presentations, his tables with all of his skills and competencies laid out in nice rigor row. So they're used to doing that kind of thing and telling us exactly what they need. And a lot of times I know advisory committees might just say, I just need somebody who can do some electronics. And getting down to the specifics is a little bit more than they're willing to dig into at that moment. So I think one of the things we can get from those certifications, the ones you mentioned, for example, earlier, are some of those skills lined up that fit under that, just something in electronics. So I think it's a good addition to our toolkit to use forward. And then Julian did the same thing, took his industry standards to kind of validate what they were doing as well. So I think it's a great to integrate those two into our academic programs, which I totally agree with Gary. The students want a degree. They want the potential to go farther in their education, and industry wants, because that's how they'll get people moving up into their organizations as well. So we do need to get them tied into our industry, into our academic programs. So I think there's just a couple ways we can use them. One, just as guidelines for our own skill sets, and the second idea is just getting them aligned so we could possibly articulate them into college credit at some point. I think I'm supposed to move my own slides here. I've just been watching them float by. Gary has already talked a little bit about the Siemens certification. And another question I have for you, Gary, about that is, are your colleges using this now? The colleges, not your colleges, the colleges in your consortium, and what value added has that given the colleges and their programs?
I think, Marilyn, the value, because we did some researching on certifications, and at the time there were not a lot out there. PMMI was soon to be offering a certification, but they didn't actually have one yet. But what we looked at certainly was, an industry credential, but we also looked at what the certification or what the partnership with the certifying entity would provide to the colleges. And we were attracted to Siemens primarily because they offer some wonderful professional development for faculty. They offer a 2-week training session on the systems level methodology, and they don't focus an awful lot on the technical skills. They assume that you would have those, but they kind of indoctrinate you on systems level thinking and systems level troubleshooting. I did not attend that. I had 2 other faculty here at CLC attend that, and we had probably a total of 6 or 7 across the consortium that attended it. And the feedback that I received from the faculty was they came back really excited in terms of the different approach to developing this content. At the time we were selecting certifications, that was really the only certifying entity that offered that professional development component, which was attractive to us. They also offer, if you're fortunate enough to be approved by them and your program to be approved by them, they also provide some marketing support for your local programs. And there are some requirements, obviously, to be certified and some cost associated with that. But at the time, we felt that it filled the void that we were looking for.
Okay, great. Some awesome comments there. I know there are a number of certifications for some of the disciplines under mechatronics and some of the electronics areas and some fluid power and maybe even some in automation. But you guys were really looking for something that would capture the entire program you were developing under your grant project.
Yes.
Okay.
Correct.
All right, Mike. And I don't know myself too much about the PMMI certification, so it is out there, and I know they're working on some new aspects to it or new parts of the certification. But we'll put the link there for you to check out if you're interested in looking into that particular set. And I'll turn it over to Mike for a moment.
Thank you, Marilyn. And I'll remind us presenters that we're a little short on time. So Marilyn, after the poll, I'll probably ask you to move fairly quickly through your remaining stuff so we have some time to turn back to Don at the end. So audience, here's a quick question for you. Now, it's not going to be a hard question. Do your industry partners require certifications? Yes, no, or you don't know. You're not sure. And by the way, if they're required, why don't you type the name of that one into the chat box. So the poll is open right now. People are already putting their answers in. A for yes, B for no, and C, you're not sure, or it doesn't apply to you because it doesn't apply to you. Okay, I'm going to only give you another few seconds. The chat window will still be open to put in the name of your certification. So here comes the poll. Let's take a look now. So Julian, Don, Marilyn, Gary, we're asking them, do their industry partners require certification, yes or no? So here's the countdown. 5, 4, 3, 2, 1. Let's go ahead and show the results of that poll right there. So the interesting thing is that I would say of the audience responding, we had a fairly large numbers saying no, or they weren't sure, and only a relatively small fraction, under 10% of those responding, saying yes, they do. So there doesn't seem to be a requirement yet for certifications. Marilyn, let's go forward and ask your question for our partners. And again, let's keep these questions short. So go ahead and ask them.
Okay, so I guess I'd like to ask Julian and Don, either or both, you're in the same facility. If, are there certifications that Global Foundry requires or is interested in, and if they're important? And then something that I always think is interesting is what role does an associate degree play in there? I always think of that as an educational credential or certification, and does it have equal value? So one of you want to take that?
Marilyn, I'm going to address the first two bullets, and Don will take on the third one. As far as I know, there's no requirement within the manufacturing side of Global Foundries here in Malta for any kind of certifications. However, in the facilities department, they do have certifications requirements for their electricians and maybe chemical technicians, I'm not sure. But facilities certainly would have certification requirements for their employees.
Okay, thank you for that.
Okay, and I'll go ahead and take your last question. Is the associate's degree or college certificate of similar or equal value? The answer is no. They're not of equal value. The associate's degree still is considered more recognizable as far as having an individual be more hireable, if you will. And the reason being is because they get the full spectrum of the education, not just the technical aspects. There is a strong push, of course, to get the associate's degree curriculum revamped to where it meets some of our needs, which we've been discussing. But ultimately, we do want to have individuals achieve a degree. In most cases, actually, even a bachelor's degree. Now, but where the certificate comes in, the certificate that we've been talking about, especially with the TAC, is of value. It's of great value, actually. As long as the individuals have previous work experience, not necessarily in semiconductor, but just previous work experience, and that certificate, they're still considered valuable because the work experience teaches them the soft skills, hopefully, that we're looking for, as far as their teamwork, able to effectively communicate, critical thinking, things like that. And then, of course, the certificate is going to give them the skills that we need. So, definitely they're not equal, but both considered very valuable. When we look at things like a Siemens certificate or others, other than facilities, our technician job roles are so different that a Siemens certificate or others would be a nice bullet, but it would not be considered credible without some sort of other support education, being a recognized certificate that we have the input in the curriculum or an associate's degree. Does that make sense?
Yes, that's a great response, because it's your industry sector has some particular needs, skills that some other manufacturing areas might not. So I think that's a great answer. Okay, I'm going to move ahead and skip over this one really fast. I want to explain this slide just a bit. We have the Jacksonville model courses laid out here on the left-hand side. That's FSCJ, and on the right is a relatively new curriculum developed by the Supply Chain Technology Education, and they deal with material handling. If you take a look at this in more detail later, you'll see they're pretty much the same. So they're also looking at a mechatronics technician that I might call mechatronics, except down in the middle here where it says high-tech manufacturing, they actually focus on the automated warehousing as an application for mechatronics. And with that, I'd like to now turn it over to Don to hear him now that we've heard from the educators, to help close this out. Don?
Okay, thank you, Marilyn. So yeah, I'd really like to go ahead and close this out with just basically some of our observations that we see that could be very good benefits from the mechatronics program. So basically, as I had mentioned earlier, we're seeing a lot of technicians coming in here with one specific skill set, but gaps in others. Some of the things that we're seeing is the holistic skills that we're getting from these programs. It's giving them the attention to detail that we need by working on these very complex systems. It's also teaching them workmanship skills. A lot of the students, when they go to an electronics program, since a lot of the metal shop and the automotive classes were taken out of the high schools, they don't have basic workmanship skills. They come in here with advanced electronics, but they don't know how to hold a wrench or work a torque wrench or things like that. So these programs are helping them achieve those workmanship skills as well. They're also getting mechanical aptitudes, as I said, similar to the automotive and aircraft mechanic. They're not just electronics technicians, but have that whole holistic skills. They're also getting very good exposure to troubleshooting, the problem solving, and the critical thinking skills that we also need from our technicians. Like I said, to get the equipment up in a very effective and quality manner. One of the other important aspects is the teamwork. When you're working with the mechatronic systems, a lot of the curriculums you can see they're separate units, but they have to all work together to make the whole manufacturing process work in these Amatrol and these other mechatronic systems. So they're able to work as a team as they work on their different systems to get the common goal of getting the product from one end to the other. And they have to effectively work with others in order to be able to do that. Some of the other benefits, aside from the technical, is they're getting some of the expectations of the required safety standards. Previously, we weren't getting the students coming on board with, they weren't being cognizant of the safety requirements, because in a lot of the education facilities, they weren't really focusing on guarding and lockout, tagout, and things like that, because they weren't really dealing with very hazardous systems. Then the students would come into our environment and they had kind of a complacent attitude when it came to safety because it hadn't been instilled. So they're building those safety standards into the curriculum, so it's basically getting those skills early, or those expectations early on. It's also decreasing training time for our new employees. Julian touched base on this, that when we have a senior level technician that's taking on a trainee and they have to go back and teach them basic hand tools or basic troubleshooting or basic problem solving, it takes a very long time to close those gaps. Not to mention the fact that it's not only taking a long time for that trainer to work with them, so the trainee is not engaged as fast. It's also draining the resources of that skilled technician. So as they're training, they're not able to work on more advanced issues because they're sitting there with that trainee for that amount of time. So it also, as we mentioned early on, as Mike asked, it eliminates the intimidation of the advanced manufacturing environment. They're able to see the tool at the component level, even though, as Gary talked about, we don't necessarily need them to troubleshoot the component level. We want them to look at the system and troubleshoot the system or modular level. They're able to see it at the component level and take away that intimidation. And I just to touch base with kind of how we support Mike and Gary in that assessment is, when it comes down to troubleshooting a board or something that's going on with our DC power supply, we don't want the technician to pull that board and repair the board. It costs too much time and downtime. We want them to swap that board, put the new board in. Currently, when we get technicians out of the associate degree program right now, they want to troubleshoot the component level because it's exciting, it's what they were learning when they were in school, and it takes additional downtime. So then we have to spend time kind of untraining them on that mentality. So I just wanted to kind of mirror what Gary was saying about that. The other big point is it's going to increase our talent pool to meet an increased ramp demands. So right now we look at students only with an associate's degree. The community colleges around here cannot keep up with our demand. This gives us an opportunity to have an additional talent pool by displaced workers or returning vets to go and get a certificate that's supported by the local colleges. We're able to double, triple, even quadruple our talent pool, because right now the community colleges, as I've done mental numbers of what's currently enrolled in their programs, we're going to get maybe anywhere from 50 to 60 students to maybe even 100 a year. Right now, this next 2 years, we're going to hire over 600 technicians. So we need to increase that pool, and I think that these students that go through these programs are going to be a great fit into our organization. So that's pretty much what we see as being the benefits in the mechatronics program. So I'll go ahead and hand it back over to you, Mike.
Thanks very much. Don, it was interesting hearing your perspective. A lot of us paid a lot of attention to the comment you made about the need, in some cases, for untraining as you referenced it, looking more at a system board level approach versus components. So that's one of the gaps I think that really do exist between what the current state of industry is. It's not true everywhere, but it's certainly true in your system. I understand that.
Absolutely.
So we appreciated that comment. Okay, so folks, we're so perfectly on time. It's just amazing today. I get to do the little wrap up here. That's my picture on the upper right. Today we discovered why industry values mechatronics, why they look for that skill, that knowledge, that ability. And we looked at an interesting approach they had to a gap analysis, working with 7 or so community colleges in their area. I think that can make a strong statement if you're developing a program or expanding your own program. Number 2, we looked at what mechatronics technicians actually do in the workplace. And through Gary and Marilyn, talked a bit more about educational approaches. I know one thing about educators, and this also came up in the chat window. You're developing a new program, you pick up the phone and call other faculty members, other educators, and find out what works. That's what happens at community colleges, so we encourage that. Number 4, we looked at some best practices for mechatronics programs. Both up in New York and Florida were some of the ones that we highlighted today. And then finally, we considered what industry looks for and why that value is there from today's technicians. I've got a question about that for Don and Julian, but I'm going to go forward for just a minute before I come back to that. Here's some concluding thoughts. Mechatronics is a growing skill set, that's for sure. These skills are transferable across many industries. So some of the advice in the chat window was don't necessarily design your program for a single industry. It's important to know your industry partners, but remember, think broadly as you design your program. And then the third bullet, educational institutions must better understand how these skill sets can be integrated into curricular offerings. All of us know you can't just keep adding things to programs, and add something, you got to take it out. So there's that balance that we're always looking for. Now today, I'd like to invite you to put your final questions, lots of questions today in the chat box. We'll get to them. But in order to help us pay the bill, I'm now going to launch a 60-second survey into the window here, and you'll be able to actually take that survey. Hopefully I can do this correctly. Oops, I'm sorry, that's the video that we weren't going to see. Well, that's embarrassing, so I'll jump back here. It's too bad that Mike didn't actually get the right link here for the survey, so let's put up with his operator error for a moment. People are smiling to themselves, that's good. All right, here we go. We're waiting for the survey to come up. I've got a question for you, Julian and Don. I'm not sure you can actually answer this one. It's sort of a funny question. Do you poach other programs for your technicians? Do you go into aircraft programs and try to sort of take them from there?
Well, I don't know that we necessarily poach, but we do seek opportunities from other industries. We do look at the transferable skills. So one of the posts that you're saying from one of the questions is don't build your curriculum, so it just pertains to one industry, and that's absolutely true. And even within our industry, we can't get so pigeonholed because, like I said, we have so many different needs from different technicians. So we do welcome other industries, aircraft, automotive. One of our biggest partners is actually returning veterans as far as nuclear technicians, aircraft mechanics, and that. We don't necessarily recruit from other companies. We tend to focus on recruiting as far as educational institutions around. But by all means, if somebody from another industry wants to apply, we'll certainly look at them.
Well, we're very fortunate to be located here where the U.S. Navy has a nuclear training facility, and so as the Navy, as the sailors and engineers that come out of the Navy, when they leave the Navy, they actually look at Global Foundries and IBM and GE in this area for employment, and so the Navy has provided a lot of technicians and engineers for this area. But back when I first got started working for Philips Semiconductor in Albuquerque, I did recruiting at Lowry Air Force Base in Colorado because they had a school there. They had an electronics training school there, and I used to recruit trainers from Lowry because they were extremely good trainers and they knew electronics very well. So they made excellent instructors, technical training instructors for us in the semiconductor business.
That's cool, Julian. Thanks for that comment. And by the way, folks, you can see the surveys finally up there on the screen. So please go ahead and click on some of those buttons. Participants and presenters, we're down to about 110 seconds left for today. So we've got to be quick here. I'm going to do a quick one for Don and Julian. Lots of discussion in the chat window today about the need for mechanical or fabrication skills. Let's call it CNC machining or running a lathe. Do you look for that in an employee that comes in? Do you want them to have that sort of hard, in a sense, fabrication skill? What do you think? Is that what you look for?
No, not necessarily. And the reason being is those skills, although they're very quality skills to have, we found a lot of individuals that have those skills in that niche and they love doing that. They come into our environment and they're not as, I don't know if happy is the right word, but they don't have the opportunity to get in there and tear down things and lathe and weld and things like that. And usually those type of people have that mindset where they like to get dirty and they like to do that sort of thing. And this, we're looking at more of a, even though the machinists need finite skills and attention to detail, the skill set seems to be a little bit different for technicians that are coming into this role. It's just like, you know, working on a CNC is a lot different than working on an aircraft, and I think that those skills, they're related, but not closely enough that the individuals are really happy with what they're doing.
Now I understand that the facilities department does have a very small machine shop, and they probably employ 1 or 2 machinists, but most of the machine work is done by contractors outside of GlobalFoundries. Okay.
Well, that's cool. I mean, that's a very frank discussion, and I bet you there's other industry segments where they're going to say, hey, we want them to have that understanding of fabrication, that sort of things. So very good. Well, folks, we're here at the end of our webinar. I'm now going to count down to the close of the survey, and we have just a couple of announcements to make. So here's the close of the survey. 5, 4, hit your last buttons. Make sure you submit. 3, 2, 1. Survey is closed. Thank you for participating in that. You're going to get an email that will allow you to access the recording, slides, and handout from today, or you can look for other webinars in our system by going to matecnetworks.org. The next upcoming webinar series, I bet you'll like this one, Digital Fabrication on April 18th. So look for announcements about that coming up. If you'd like a certificate of certificate of something today, just go ahead and email Janet. You can see her email right there, janet.pinhorn. She's going to check to make sure your name is actually on the list today before she sends that certificate to you. Join us in Chicago, Illinois, July 21 through 24 at the High-Tech Conference. Julian talked about it. It's just a great event. And note this, look at the bottom of this slide. There's a workshop, Implementing a Systems Approach to Mechatronics Education. That's on July 21, so that sounds like it would be worth your while to go to Chicago. Great time to be there in the summer. I'd like to thank our participants and our presenters. Julian and Don, thanks for your time out of your busy schedule today. Marilyn, thank you for calling in from your travels up in Virginia, and from the Midwest. Gary, thank you very much for joining us and giving your perspective. So that officially concludes our webinar for today, Mechatronics, What You Need to Know and Do. Thank you for attending, and thank you, presenters. Goodbye, everyone.